part. I'm halfway. Yeah. So let me run this slide halfway. So get to this point. Yeah. And then let me recall a little bit. So then I finish this slide. Yeah. And this, oh yeah, we are at this property part. Yeah, before this property. Yeah, we're here. Right. First, let me recall a little bit this concept, this important concept. Oh, the lava here. For this concept, first, it's important for business. When we use our databases in business applications, so this type of operation, very important, because we need to protect our business data. Yeah. So the idea is when we define a transaction, database transaction, we have a business task. For this business task, there is a group of query operations. We have to treat them as a whole block of operations. We cannot separate them. If you separate them for any reason, something could be wrong. Yeah. So in order to, make sure you never execute that block of code partially. Yeah. So this concept is defined and it must be implemented in supported by programming languages. Yeah. Yeah. So here, let's consider the implementation part. The implementation part here, I list these 4 steps. Yeah. The first step, you need to define the starting point of a transaction. Where is your starting point? Because later you need to find this point. If something is wrong, you need to, get back to this point. Roll back to the point before this line. Yeah. Then, after that, you provide a sequence of queries for a task. That's the definition of your task. A block of, a group of query operations. Then the end, to mark the end of the transaction definition. What is the end? You need to issue some action called commit action. Commit, yeah. So you put a group of query operations together, but you need to tell the DBMS, execute this block of code. So you send a command called commit command. Commit. Okay. Then DBMS must execute the whole block at the same time. Yeah. If something wrong, when the DBMS execute this block of code that define a transaction, something could happen, something wrong. Yeah. Then the last one, roll back if there is an error. Yeah. In Java, we know there is some exception could be thrown, right? Yeah. Java handles this by exception. When an exception is thrown in the middle, yeah, during your execution of that task, transaction definition, some exception is thrown, then you need to execute the callback code, callback code, yeah, because the catch block for that exception, you can define your callback code. Yeah. Try to recover the original state before the transaction. Yeah. And if you change something, you need to recover. Yeah. In your callback code, you need to recover. Do not make sure, do not cause any damage. Yeah. So that's the whole idea. Yeah. And for this important concept, in my plan, I try to show you a few examples. 2 examples should be enough. One Java example, one PHP example. Yeah. So, and if you are interested in play around, yeah, so you can execute those examples to get idea. Yeah. And you can look at the code, yeah, how to implement these 4 steps. Yeah. All right, now let's discuss the properties for this concept, transaction concept. There are 2 properties, 2 important properties. The first one we call the isolation property. Isolate. So your transaction, that group of code must be isolated. No interference with other transactions. Now, in your DBMS, you may have many transactions, right? Yeah. Not only one. Your DBMS may need to execute multiple transactions at the same time. So each transaction should be isolated from other transactions. No interference. Isolation. So this property. Yeah. No interference from other transactions. That's the simple requirement. Yeah. The first property. Second one, also important. Yeah. The second one is called atomicity. Atomicity. Atom. So atom, right? The particle, atom. Yeah. So here we use some very old meaning of atom. Ancient meaning of atom. In ancient time, people feel atom cannot be separated. Ancient time, not modern time, not current. Current, we know atom could be separated, right? But at ancient time, yeah, people treat atom can never be separated. It is the smallest particle in the world. Yeah. Here we use this atomicity terminology. We mean this transaction block of code can never be separated. All right, we borrow that meaning. Okay, yeah. And its meaning is all or none database operations are executed. All or none. You either execute all operations or 0 non-operation. Yeah, no partial. Yeah, because here I cover that all. Yeah, because I wrote this last time. Yeah, so this annotation, software. If I wrote now, I can erase it. But if I wrote last time, the software does not allow me to erase this whole thing. Yeah, so it covers that all or none thing. Yeah, all or none. Yeah. So, all right. Yeah. So that's the meaning. These 2 properties, transaction. Yeah. All right. So I spent quite some time because it's important. Yeah. All right. Then let me move to next concept. Yeah. Next concept closely related to transaction. Yeah. But that's the responsibility of your DBMS, not our programmers. Our programmers, we do not need to do anything. Here for transaction, we need to write our transaction code. Okay? Yeah. So we need to do a lot of coding. The current DBMS. It is very important. Otherwise, your overall performance of your DBMS would be very slow. Yeah, let me explain this. Concurrency, concurrency. Okay? Yeah. That means multiple database requests need to be processed at the same time by your DBMS. Yeah. Especially in our web application. So you can imagine if some very important web application running at some busy time, many users need to send requests to this web application, and a lot of queries need to be executed concurrently. Yeah. So then your DBMS should support this kind of concurrency very well, right? Yeah. But for us, we programmers, we do not need to do anything. When we write the code doing transactions, database transactions, the transactions rely on this concurrency control feature in DBMS. Yeah. Otherwise, we cannot get transaction work in the right way. Yeah. So transaction relies on this feature. Yeah. All right. This feature support several users trying to update the same data, do so in a controlled manner. How to control that kind of detail, we do not need to know it. That kind of detail must be in some controlled manner. Okay. Multi-threading. Do you know for multi-threading, the concept, the technique, multi-threading technique? If you learn this multi-threading technique before, you can imagine, we can, the inside DBMS, it can use multi-threading technique to do this concurrency control. Okay? Many users, you submit requests asking for database queries. They're multi-threading. Many threads are generated. Each thread, so you provide service to one user by one thread, right? Send one thread for one user, another thread for another user, multiple threads for multiple users. But all those threads, large number of threads, should work in a well-organized way. Otherwise, the data could be messed up, right? Yeah. So you change the data, another user changes the data. So, so many users need to change the data at the same time. How to make sure the data is changed in the right way? Yeah. Multi-threading technology is designed to make the change of all users in the right way. So we do not need to worry about it. Okay? So we do not need to do anything. Yeah. So this feature, already built inside the DBMS. Okay, yeah. So you just know it. Yeah. All right. A good DBMS must include this feature. Yeah. So modern, powerful, strong, powerful DBMS must include this feature. But not that good. Some DBMS is not that good. Some DBMS is not that powerful. Yeah. Some DBMS could be weak, right? Yeah. Small, weak DBMS. Those relatively weak DBMS, they may not have this feature built in. Yeah. Because you need to use a lot of resource to support this feature. Here, I like to give you a simple example showing you some relatively weak DBMS may not support this feature. One, Microsoft Access. That's for personal business, right? For very small business, or most of the time for personal business. Okay? Yeah. So here there is an older version and a newer current version. Older version, no concurrency control, nothing. Okay? No support for concurrency control. That's the 10-something years ago, the older version, Microsoft Access. Only one user can be used at one time. Okay, but recent version, that part that is changed. So right now you can see it supports 255 concurrent users. So we can treat as the limited support of concurrency control. Limited support. This many users can use concurrently. So much better than before. Much better than before. Yeah. But you need to be aware of, you should not use Microsoft Access, this database management system, to support even mid-sized business, because it's not enough. Okay, it's not enough. Yeah. So yeah, I know this. There is some real-world application. Yeah. So using Microsoft Access. Yeah. Long time ago, no concurrency control. At that time, the performance is extremely slow because the user, they need to wait in line. Okay, user one, after you finish everything you need, then it's user two's turn, user three's turn. So then at the busy time, it's very slow, extremely slow. But now with 250 concurrent users, so that many users, you can get database queries at the same time, so much faster, but still slower than like MySQL. Yeah. Because MySQL, it is much powerful in concurrency control. Yeah. So large number of hundreds of users, even thousands of users, you can access the database at the same time without big delay, lagging, you can notice. Yeah. But for Microsoft, when users, hundreds of users, you will see a significant lagging. Yeah. I saw that kind of thing. Yeah, phenomena. Yeah. So people experience significant lagging. Yeah. When they use the web applications. Yeah. All right. Yeah. Yeah. So this experience tells you, if you need to choose a good DBMS for small or mid-sized business, it's better to choose MySQL, not Microsoft Access. Sooner or later, you will feel, it's not good for even small business. All right. Yeah, transaction feature requires this feature. Yeah. All right. Yeah. All right. So that's the experience. Yeah. But here you only need to know. Yeah. Because here I cannot show you examples. Yeah. I just tell you a little bit about my experience. Something I noticed. Yeah. In my daily life. Yeah. All right. Next big concept, another big concept. Yesterday I used this, but I didn't explain this. So today, let me explain this concept completely, called a stored procedure. Stored procedure. So what's the procedure? So for the procedure, that's just what we usually call functions. Let me give you the background of stored procedures. Functions, we define functions, okay, procedures, at old time, people call it procedures functions, right? So if you learn some old programming language, so very old programming languages, people call procedures functions. This terminology came from the old time, because SQL very old. Think about SQL language, very old. Okay, so the terminology, older term still used. This procedure, just a regular function. But this function, we need to write using the SQL language. We use SQL language to write the definition of procedures. Yeah. So here you can see, yeah, thus the procedures written by SQL statements. Okay, yeah. So you can see SQL actually you can treat as a high-level programming language. We can write code. Okay, we can write functions. Yeah. Other than queries, so we can do, you know, the basic things that high-level programming language can do by SQL. Yeah. Here, yeah, this procedures. Yeah. Later, I will show you some examples. Yeah, show you some examples, code examples. Yeah. And stored. Yeah. So what you call it stored? Yeah. Stored inside DBMS. Yeah. So this you use SQL, but stored inside DBMS. Yeah. So we call it stored procedure. Yeah. In form of functions with input and output. Function you need to provide input. Then sometimes you may have output, but sometimes you don't have output, right? Yeah. Some functions does not return anything. Void function. Yeah. Void function, no return. Okay, that's possible. Yeah. So, yeah. So here, yeah. So we have these two cases. Yeah. Written in SQL, yeah. Execute a sequence of SQL statements in DBMS. Yeah. And its definition is stored inside DBMS. Yeah. So we treat it as part of database definition. And it belongs to the metadata part. Metadata, okay? So secondary data, not primary data, not primary business data, secondary data, okay? Stored procedure. All right. And when you export the database, the definition of stored procedure also export it. Yeah. Because when you, so here, sometimes you need to export your database. Its definition, yeah. Stored procedure, yeah. Its definition is included in the script. Yeah. .SQL file, right? It contains, that script file contains large number of SQL statements, SQL commands. Yeah. Stored procedure. Okay? Yeah. All right. Can be called locally and remotely from the application program. Locally first. Yeah, let's look at locally. Local machine, yeah. On the machine, yeah. You run your DBMS server, yeah. So on the same machine, remember last lecture, I show you that command window, SQL command window, okay? Yeah, in that SQL command window, remember, I click that SQL tab, there is a tab, all right? After you click the tab, you have a command window, okay? You can type command, okay? So here, if you call locally, you type this command, just call. Then you need to have a procedure name, okay? For example, here I just type my procedure, enter, go, okay? So this function is executed. Yeah. But if there is input, then you need to consider how to provide the input, right? So that kind of details. This is the local way. Right? Then remote way. Remote way. Remote way, you need to call it inside your application programs. Inside your Java programs, inside your PHP programs. Yeah. So you need to embed your SQL command in your Java code or PHP code. Yeah. So inside double quotes, yeah, SQL command is inside double quotes. Yeah. So you call some function. You call some function. Inside the function, double quotes, call your procedure name. Then you send that command to the, from remote server, you send it to remote machine. Yeah. So the store procedure is executed with this remote command. Yeah. So you can see, yeah. And in this way, you will see, yeah, this way actually has a lot of benefits. You can enjoy a lot of benefits. We call remote procedure. There is some important performance improvement if you do it this way. Yeah. Here, let me explain. This way is quite useful. Let me explain a little bit. Yeah. Can be created in application program. Yeah. So this here, it means we can define stored procedure in our application programs. We can write the procedure definition inside our application programs. Yeah. Yeah. There is such capability we can do. Okay. Yeah. If you are allowed to do that, that's another issue. It's a business decision, right? If you're allowed to do it, that's a business decision. All right. For DBMS, it supports this capability. Yeah. So we can write store procedure definition in our, for example, Java programs or PHP programs. We can define. Okay. Yeah. All right. Can reduce data traffic on internet. Here, I like to explain this benefit. I said there is some important advantage for this feature. We call remote stored procedure. If we compare it to local call, remote call, the remote call has some advantage. Yeah. Think about this way. Yeah. In our stored procedure, we can do a lot of data processing work, right? You can imagine in your function definition, you need to execute many query commands. And those query commands would return data, right? Return query data result. And inside that function, you may need to process the data, right? Process the data. After you process data, then you do some other query operations. Think about that procedure, that whole process. All right. Now, if you do not use store procedure, okay, you need to do that same sequence of queries. How you do it? Think about. So without store procedure, here, let me describe. Without stored procedure. Okay, yeah. You need to do a lot of query operations, right? Yeah. Okay. So here, suppose we have two servers. Server 1, server 2. Okay. Server 1, we use it to store our business data. Okay. Server 2, we use it to run our web application. Two different servers. That's quite normal, right? One server, data devoted to data operations. Another one for web applications. All right, separate, two different locations. Yeah, could be far away. Okay, they could be in different countries even. Okay, different countries. All right. Yeah. Then, can you imagine between these two servers, a lot of data communications between them? Can you imagine? Yeah. Because think about it. Suppose you have a business task, you need to execute 10 queries. You need to execute 10 queries for one particular business task. Okay. Then your web server, you send a request for first query, do first query in that remote database server. Then it returns the query result. You get it. Then you do some manipulation. Okay. Then you send another query number 2 to the database server, and the database server returns result. Then you do some more manipulation. Then number 3, number 4, number 5, until number 10, you complete all your business data processing work. Think about how much traffic you need. Back and forth, a lot of traffic, right? All right. A different way here. Let's choose the stored procedure way. Okay, so here, store the procedure way, right here. Okay, store procedure. So then, remote web server, you only need to send one command, call that procedure. Okay, call that procedure. Then, all the data operations, queries, and the processing work all executed inside the database server. And that database server does not need to send intermediate results back to the web server, right? So it reduces a lot of traffic sending intermediate result. Intermediate data, not necessary anymore, right? Yeah. You just do all the data manipulations, processing work locally at the same place, same server. Okay? Yeah. But this procedure, this function, you only need to send the final processing result back to the web server. That's enough. The final server back, final result back, right? You can see in this way, a lot of internet is reduced. Much more efficient, much faster. You will see the response time much faster. Yeah. So this is one of the biggest advantages of this way, stored procedure way. One of the biggest advantages. Okay, yeah. So it's important. Yeah. Yeah. So for this technique, yeah. So let's treat this technique. I plan to put it in our third programming chart. I try to add a small stored procedure in the requirement of our third project. Okay, so let you feel about it. Right? Yeah. So you need to define, create, then you need to call it, then you need to, see the result. Yeah. So very simple, but you need to feel about it. You need to have some experience using this technique. Yeah. Okay. Yeah. All right. Yeah. But number 3, I try to add one small feature using the stored procedure. Yeah. All right. Yeah. Improve performance, that's one important advantage. Can enforce business rules. Business rules, enforce. Yeah. So this topic also very important. Yeah. We know in our business, we need to enforce many business rules, right? Yeah. So the data, when the user enters data, we need to check if the entered data follows the business rule. Yeah. Yeah. Some of the business rules could be very complicated. Okay? And you don't want to do the manual way, right? You don't want, people, although you can do the manual way, but it's not efficient. You need a lot of manpower, okay, to look at the data and check the rule, and make sure it follows the business rules. How many manpower you need to use? More efficient way, you can write a stored procedure. Okay, use the code to check. Okay, yeah. So this, yeah, you can have a list of rules. Yeah, one by one, checking. Right, that's much more automatic checking, much more efficient. Checking business rules. So you can see this is another big advantage using stored procedure. Automatic, okay, yeah, checking business rules. Yeah. Even if the rules could be very complicated, because it's hard to memorize. For human, it's hard to memorize the complicated business rules, right? Yeah, many times. Yeah. So you may get confused. You need to search the document, okay? Your business rule document, Yeah. So not efficient and error prone, right? But using the stored procedure, automatic, very fast, very efficient. Even you have some very thick business rules document, Yeah. Although it takes a lot of time to develop these procedures, but after you get it done, you enjoy the, great performance result. So that's another advantage, important advantage. Yeah. All right. Then I can give you the third advantage also. Yeah. I think I didn't put here the third advantage. Yeah. So before I move to the next topic, let me also give you a third advantage, also pretty big. Yeah. The third one also related to web applications. Yeah. For web applications, think about currently to develop a large web applications, you may need to use multiple web servers, not just one, many web servers to run one integrated web application. On each server, you implement some of the features. Another server, another part of the features. All right? So all those features integrated together, you have a huge, big web application. Think about that scenario. Okay? Yeah. In that scenario, there is another complexity that could happen on different web servers. That is, different server, they can use different programming language. Here it use this one using Java, another one use, PHP, another use, Ruby on Rails, another, we know there are many different web technologies, right? Yeah. Some could use Python, for example. Yeah. It's possible, right? Yeah. Some of the features need to use Python to implement. So you want to make all different programming language work together in the same web applications, how to do communication, right? It's complicated to do communication, okay? Yeah. So the store procedure can simplify part of the communication work, part of, not all, part of, because all those programs in different programming languages, they can call the same stored procedure, right? Yeah. So these operations, if I move to a different programming language, I can call my stored procedure, but I do not need to write new code. Okay? I just call that remote stored procedure. If I do not use stored procedure, if I write it in Java, but in PHP, if I want to use the same data processing task, I need to write it in PHP, right? Then if I move to Python, I need to use the same business task. I need to write it in Python, right? Yeah. But if you have one version stored procedure, then you move to all different programming languages, you just call that. You don't need to rewrite the code. Okay? Yeah. Same SQL code, you can call all those different servers. So that's another scenario. So you get advantages for stored procedure. Yeah. All right, so let me finish right here, yeah, because I already spent too much time. Yeah. So let me quickly, because this concept very important. So I spend a lot of time here. But let me jump to the new content quickly. Yeah. All right. Yeah. All right. So part B, yeah. It's called a data normalization, this concept. Yeah. Another important concept. Yeah. Important in database design. Yeah. So let me explain this concept. Data normalization concept. All right. B.1, redundancy problem. Redundancy problem. Okay, yeah. So in our database design, we may need to deal with this kind of redundancy problem. Let me describe it first. Yeah. Storing the same data multiple times. Yeah. Because you may have several tables. In table 1, you store some original piece of information, but in some other tables, you may store the same piece of information another time. Okay, that could happen. That kind of redundancy could happen. Yeah, in database design, especially you have a large database, right? You have a large, complicated database. How can you avoid storing any redundant information? Some special information that could appear multiple times in your large number of tables. Think about you have hundreds of tables, right? Hundreds of tables. Nobody can guarantee your data storage not redundant. Okay? Yeah, it's hard. It's hard. Okay? So it's pretty common. Some pieces of information could be stored multiple times. Yeah. So that's the redundancy problem. Yeah. For us, we try to reduce that occurrence, right? Yeah. Redundancy, yeah, because it has some disadvantages. Yeah. First, let's see the disadvantages. Duplication of effort. Yeah. So the same piece of data, you need to enter into those tables multiple times. So that's the duplication of effort. Okay? Yeah. More effort, more than necessary. Yeah. So that's the first thing. The second thing, right. Yeah. So here, that could cause the problem when you update the data, right? Yeah. When you update the data, yeah. Because logically, there is only one single piece of data. Yeah. If you do not have the redundancy, you only need to update it in one place. But when you have redundancy, you may need to update it in multiple places. Multiple places. Okay? So that's not efficient. Especially, there is another bigger problem than efficiency. If you forget to multiply all those places, so what would happen? Right? Yeah? You may forget to update everywhere. You use the same piece of data, right? Then you have the data inconsistency problem. Inconsistent. Your data inconsistent. In one table, it's this value. Another table, it's a different value. Okay, that could happen. That could happen. Yeah. In my everyday experience, I saw this kind of thing. Okay. Yeah. One user update his or her account. Yeah, because one user wants to return the money, right? Yeah. Drop the course, right? Drop the course, then return the money. But that information is not updated everywhere. So one place you see, oh, yeah, the course is dropping, the money returned. But another place, another table, no, not drop it, still there, right? So that problem is much bigger. Data inconsistency. So you need to fix that. Okay? Yeah. Yeah. For your business, you need to fix that. Yeah. Wasting storage space. Yeah. So you need to use more storage space. Yeah. More, another disadvantage. Yeah. All right. So same data stored repeatedly. Okay. Yeah. Yeah. All right. Then this is the biggest one. Actually, duplication of effort, wasting storage space, not as big as this, the third disadvantage. The third one, inconsistent data. That's the disaster for your business, right? Yeah, that could cause big problem in your business. Yeah. So this is definitely, it's not allowed. Yeah. The first two, we can take it. Think about duplicate effort. Yeah. So, you know, yeah, we do a little more work, right? The second, wasting storage space. Yeah, we use a little more storage space. Okay. Oh, yeah, but not a big deal, right? Yeah. But the third one, you know, we don't want to have it. Inconsistent data. We have to fix it. Whenever we see something inconsistent data, we must fix it as soon as possible. Yeah. Otherwise, your business could have a lot of loss. Yeah. All right. Yeah. Files that represent same data may be inconsistent. Yeah. Yeah. So you can imagine that could happen. I saw, you know, in my experience, I saw this kind of things. Yeah. All right. The file. Yeah. Here, the terminology file. So why? So in this context, in our database context, yeah, many times we use this term, file term. Yeah. In our context, the meaning of the file could be different from our, you know, other context. Other context, we know the file, right? So the file here, there is another special meaning. Yeah. That corresponds to table. Table. One file corresponds in our business, in our database context, corresponds to one table. Why? Yeah, I can explain this way. Inside DBMS implementation, how to store tables inside DBMS. Each table is stored as one physical file. Okay? Internal, underlying storage. One table corresponds to exactly one physical file for it. Yeah. So that's the reason some people, researchers, sometimes they also refer files as tables. No. No. It's special in our context. All right. Yeah. And because here we talk about physically, right? The storage physically, physical storage. Later, there is another way to store table content, not physically, virtually. Virtual, not physical storage, virtual storage. Yeah. Yeah. What's that? Virtual. Okay, virtual storage. Yeah. So we will see that. No physical storage, only virtual storage. Yeah. Another interesting concept. Yeah. So we will see that. Okay, all right. B.2, concept of data normalization. After we understand redundancy, we want to remove it, right? This process, removing redundancy, data normalization. So we will do in C.2, let's learn this data normalization concept. Yeah. All right. Ideal situation. Yeah. So ideal situation, we want to remove all the data redundancy, right? Yeah. You don't want any data redundancy, right? Ideal situation, think about that, okay? Yeah. Store each logical data item in exactly one place in the database. You can see this way, there is no redundancy. The redundancy factor is zero. Zero redundancy. That's the ideal case. But there is the problem. Can you get it? Right? Is it possible to get it? Yeah, that's the first question. Second question, if it's possible, suppose sometimes it's possible. Okay? Do you want to have it? If it's possible, do you want to have this ideal situation? Think about these two questions. Yeah. So let me explain these two questions here. All right. All right. Logical data item. Yeah. So we know. Yeah. So so each data piece, for example, the first name of one person. So that piece of information, we only want to have one copy, one place. Yeah. So we treat as one logical data item. Yeah. All right. So a data item appears in multiple tables with different field names for convenience. Yeah. Yeah. So here it answers this question. Why some special data item could appear multiple places in multiple tables? Because for convenience. Here, it gives you the reason. Yeah. Sometimes people know this specific data piece appears multiple times, but people do not want to remove because they want to have this convenience. That's one of the reasons people keep redundancy. Okay, convenience. Yeah. So, all right, yeah. The benefits. Data normalization, the benefits, let's look at the immediate benefits first. All right, yeah. Save storage space. Yeah. After remove as much as possible data redundancy, we can save some storage space. Yeah. That's the first benefit. Easier update, another one. Yeah. Because you do not need to update so many different places. Easier updates. Okay, yeah, that's good. All good. All right, yeah. Only change one copy. All right, yeah. Ensure data consistency. Yeah, that's also a good one. You change one place, and you do not need to look other places because you only have one logical data piece, data item there. There is no inconsistency, right? You don't worry. The inconsistency problem caused by that logical data piece update. All right, yeah, okay, yeah. Then the question. Yeah. So after we understand the benefits, the next question is, should we always make our data normalized? This question. Yeah. Should we always make our data normalized? Yeah. This question is important. Yeah. Let me answer this question. Yeah. All right. The first thing, yeah, to normalize the data, it could be hard to normalize the data, the first thing. Yeah. First, we do not answer we should or not. Yeah. The first thing is it could be hard to normalize the data. Very hard, actually. Very hard to normalize the data. Right? Yeah. And sometimes it could be impossible. Yeah. Too hard, impossible. That could happen. Yeah. That could happen. Yeah. In that situation, you do not have to, right? Yeah. So you just do the best you can to reduce the redundancy, but you need to leave some redundancy. Yeah. It's too hard to remove that redundancy. So you still want to keep a little redundancy. Yeah. So that's the first situation. The second, it's possible to remove the redundancy, but we still choose not to remove it. Yeah, that's the second situation. The second situation is it is possible to remove the redundancy. But we still choose not removing it. Let me explain this situation. Yeah. The reason is there is a consideration because we have another big important consideration in this situation. There is a performance consideration. Performance consideration. Because if you remove the redundancy, all right, yeah, there your performance could be slowed down greatly. That's the sacrifice. We don't want to pay that much cost, right? The performance could be much slower. Yeah, so let me explain this scenario, this situation. Yeah, in that one, we're willing to leave that redundancy because we want to have faster performance, right? We know faster performance, response time, extremely important in our applications, software applications. Yeah, here, let me explain a little more. Yeah, why redundancy can help improve performance, right? Yeah, let me explain that. Think about, there is a situation because in some business, we collect original data. Yeah. First, we collect original data. After we collect original data, then sometimes we need to process the original data to generate some derived data. Derived data. Yeah. Derived data is not original data. Okay. Based on some special algorithm, we generate derived data. Later, I will give you that situation, that derived data. Derived data not original. Yeah. So derived data relies on original data, but we generated the derived data based on some algorithms. Okay. When we apply certain algorithms, we can generate derived data. All right, think about if we have some very complicated algorithms, and we need to take a lot of time to generate derived data. We know derived data, that's redundant, right? Yeah, because they rely on the original data. If we throw away the derived data, we can generate another time, right? Yeah, because we can recover. We can generate the derived data another time. We just run the same algorithm another time, right? Yeah. Here the problem is we are willing to store the derived data because we can save generating time. Imagine your algorithm is so complicated, it takes a lot of time to generate derived data. After that, do you still want to throw away? Right? It takes months, years, generate derived data. You want to keep. So in that kind of special situation, you are willing to store redundant data because you save you a lot of work, save you a lot of generating, processing work. You just feed, you just send derived data, or you just do a little more extra data processing and send back the result to your customers immediately. Save a lot of time. Okay. Later, I will give you a famous case study example. Yeah. Today I don't have time. Yeah. Yeah. I just have about 5 minutes. Yeah. Today I can not give you that big story. Yeah. So next time, part C at the beginning, let me give you that big story. Yeah. That big story is Google search engine. Think about Google search engine. How to make search engine work. Yeah. How to make search engine work. I want to talk about that story. Okay. We know search engine, the performance very fast, right? When people type keywords, they get search results immediately in some fractional seconds. Millions of search results in fractional seconds. How can that happen? How can get millions of search, web pages containing your keywords in fractional seconds? How can that happen? Here, related to what we are talking about here, because there is some sophisticated algorithm behind it that generate derived data. Yep. Large amount of derived data generated. It takes a lot of time, but your search engine, your search results rely on the generated data. Okay? Yeah. The reason you can get fractional second response time because it relies on that big part of the generated data. Yeah. Next time. Yeah. I still have a few minutes. Yeah. But I leave that story next time. Okay. All right. Control the redundancy concept. Control. Yeah. We allow redundancy, but we want to control the redundancy, not out of control. Out of control, when you update one piece of data someplace, you do not know what other places you need to do the updates. Yeah, because out of control, you get lost. Okay, you cannot keep track of all the places containing the same data piece. Yeah, so that's out of control. You want to get a control. Yeah, when I update one piece of it, I know everywhere. All right, all the places with the same data piece. Yeah, I need to update everywhere. All right. Although the redundant work, but sometimes I need to do that. Yeah. Sometimes due to some reason, yeah, I need to keep multiple copies. Okay. Yeah. Yeah. All right. Control the redundancy. All right. Why sometimes redundancy is not a bad thing? Yeah. Not a bad thing. Yeah. We can take advantage of the redundancy. Yeah. All right. performance consideration on relatively complex queries. Yeah. Complex queries here, you may have a chance. Yeah. So when you work in the real world situation, you may have a chance. Your query could be huge. You can imagine you need to write that query statement in dozens of lines, not 1 or 2 lines. So some complex query could be, dozens of lines, huge big block of code. We can imagine that. Very complicated, complex queries. Okay, yeah. If you need to use some complex queries to generate some special pieces of data, you may want to store the redundant, that copy, right? Yeah. Because the generating cost could be quite expensive. Yeah. So think about that situation, right? Yeah. Derived data comes from multiple tables. Yeah. We use so many different tables and manipulate here, there, after many rounds of processing, you finally get some special data. Think about that. That could happen. Yeah. Then you may like to store the redundant data, right? Yeah, because they're not original data. Those pieces, they're not original data. They're generated, derived data. Okay? Yeah. So the queries to generate data are relatively time consuming. Yes. Very time consuming. Yeah. When that happens, you would rather spend a little more money on the storage space, right? Storage space, people can accept that cost, extra cost, right? Yeah. Pay some extra cost in storage space. Yeah. But you can get a much faster result. Faster. Yeah. You save time in getting the query results. Yeah. All right, let me stop here. Yeah. So next time, let me complete the remaining part. Remaining part, we have some important discussion. Yeah. So I'll finish next time. Yeah. Google search engine story. So we will finish next time.